Imagine a sky torn apart by fire and steel. For the young men of the American 8th Air Force in 1943, the skies over Germany were not a battlefield. They were a slaughterhouse. Every mission deep into the heart of the Reich was a roll of the dice with death. The target for the bombers, the B-17 Flying Fortresses, was the industrial heart of the Nazi war machine. But to get there, they had to fly through a gauntlet of the world's most experienced and deadly fighter pilots, the aces of the Luftwaffe. The American escort fighters, the powerful P-47 Thunderbolt and the twin-engined P-38 Lightning, were formidable aircraft, but they had a fatal flaw. They were thirsty. Their engines drank fuel at an astonishing rate, giving them what the crews grimly called short legs. They could only escort the bombers part of the way. Then, at a predetermined point on the map, they would be forced to turn back, leaving the bombers alone, unprotected, deep in enemy territory. For the bomber crews, the moment the fighters wagged their wings and peeled off for home was the moment their blood ran cold. On October 14, 1943, a day that would be forever known as Black Thursday, this brutal reality reached its horrifying climax. During a raid on the Schweinfurt ball-bearing plants, the Luftwaffe tore the unescorted bomber formations to shreds. 60 flying fortresses, each with a crew of 10 men, were shot out of the sky. That was 600 men, killed, wounded, or captured in a few terrifying hours. The losses were catastrophic, unsustainable. At a rate of nearly 25% per mission, an airman's tour of duty was a statistical impossibility. The daylight bombing campaign, the cornerstone of Allied strategy, was on the verge of collapse. General Ira Eaker, commander of the 8th Air Force, faced a terrible choice: stop the bombing or find a way to protect his boys all the way to the target and back. Could the answer to the carnage over Germany be found not in a top-secret American laboratory, but in a forgotten contract with the British? A year earlier, in 1942, North American Aviation, a relatively young company, had delivered a new fighter plane to the Royal Air Force. It was called the P-51 Mustang. Designed and built in a miraculous 120 days, it was a sleek, beautiful aircraft. But it had a problem. At its heart was an Allison V1710 engine. This was a perfectly good American engine, a workhorse that powered other fighters like the P-40 Warhawk. It performed beautifully at low to medium altitudes below 15,000 feet. In that arena, the early Mustang was a world beater, faster and more nimble than almost anything in the sky. The British loved it for low-level reconnaissance and ground attack. But the air war over Germany was not being fought at 15,000 feet. It was being fought in the thin, freezing air of the stratosphere at 25, even 30,000 feet. And up there, the Allison engine gasped for air. It was equipped with a single-stage supercharger, a mechanical pump that forced air into the engine. As the plane climbed and the air thinned, the supercharger simply couldn't compensate. The Mustang's power would drop off dramatically, leaving it slow and sluggish. A German Messerschmitt Bf 109 or a Focke-Wulf FW 190, with their advanced, mechanically sophisticated superchargers, could literally fly circles around it. For the American High Command, the P-51 was a disappointment, a dead end. It was a racehorse built for a sprint that found itself in a mountain climbing competition. It was fast, it was beautiful, but it couldn't breathe where it mattered most. The plane that was destined to save the 8th Air Force was, for now, completely unfit for the job. The man who would design the ultimate German killer was himself a German. Edgar Schmude, the chief designer at North American Aviation, was an immigrant who had learned his craft in the burgeoning German aviation industry of the 1920s. He had even worked for the Messerschmitt Company before coming to America. Schmude was not just an engineer, he was an artist of aerodynamics and a pragmatist of production. His design philosophy was rooted in a very German obsession with efficiency. He believed a fighter plane should be a perfect marriage of three things: raw speed, clean aerodynamics, and simplicity of manufacture. He wasn't interested in designing a complex, temperamental machine that only a genius could build and only an ace could fly. He wanted to build a weapon that could be mass-produced by the thousands and flown effectively by the average 20-year-old pilot fresh out of training. When you look at the elegant, uncluttered lines of the P-51, you are seeing Schmood's philosophy made metal. There is nothing wasted, nothing superfluous. Every curve, every rivet was designed to serve the purpose of speed and efficiency. His experience in Germany gave him a unique insight into the enemy he was now tasked with defeating. He understood their design principles, their strengths, and their potential weaknesses. In the lean fuselage and razor-sharp wings of the Mustang, you can see the ghost of the Bf-109's own design principles, an obsession with minimizing cross-section and drag. Schmood was about to take that shared philosophy and turn it back against its creators, building a machine that would beat the Germans at their own game. He had created a near-perfect airframe, a body with the heart of a champion. The only problem was it had the lungs of a marathon runner at sea level, trying to compete on Mount Everest. What made Edgar Schmood's design so special, so slippery through the air? The secret was not something you could easily see. It was hidden in the very shape of the wing itself. Schmood and his team at North American were among the first to incorporate a radical new technology developed by the National Advisory Committee for Aeronautics, or NACA. It was called the laminar-flow airfoil. To understand its genius, you have to think about how air moves over a conventional airplane wing. On a typical wing, like that of a Spitfire or a Bf-109, the thickest point is relatively close to the leading edge. As air flows over this curve, it quickly becomes turbulent, creating a swirling, chaotic layer of air that clings to the wing's surface. This turbulence creates a significant amount of drag, acting like an invisible brake, holding the aircraft back and forcing the engine to work harder. The laminar flow wing was different. Its thickest point was much farther back, closer to the middle of the wing. This subtle change in geometry had a profound effect. It allowed the air to flow smoothly, in clean, undisturbed layers, or laminae, over a much greater percentage of the wing's surface before it eventually separated into turbulence. The result was a dramatic reduction in aerodynamic drag, as much as 40% compared to a conventional wing of the same size. This was not a minor improvement, it was a revolution. It meant that for the same amount of engine power, a plane with a laminar flow wing could fly faster, and more importantly, much farther. The wing was a masterpiece of efficiency, wringing every last mile out of every single gallon of fuel. Schmood had designed a body that was almost perfectly clean, an aerodynamic scalpel. It was just waiting for a surgeon's hand and a powerful heart. The problem of the Mustang's weak, high-altitude performance remained a frustrating dead end until a British test pilot had a moment of pure, simple genius. His name was Ronald Harker, a pilot for the Rolls-Royce Engine Company. While testing one of the early Allison-powered Mustangs in 1942, he was struck by the same paradox that everyone else saw. It was a brilliant airframe handicapped by a breathless engine. He described it in a memo as a plane with superlative handling and aerodynamics, a potential war winner that was being completely wasted. Then he asked a simple, transformative question. He looked at the superb airframe of the P-51, and he looked at the legendary engine his own company produced, the Rolls-Royce Merlin, the very same engine that powered the Spitfire and Hurricane. The Merlin, specifically the new 60 series, had a technological marvel that the Allison engine lacked, a two-stage, two-speed supercharger. It was, in effect, a mechanical set of high-altitude lungs. Harker wrote a now-famous memorandum on May 30, 1942, suggesting the seemingly obvious. What if we put a Merlin in the Mustang? On paper, it was a brilliant idea. In reality, during the height of a world war, it was a bureaucratic and engineering nightmare. It meant mating a British engine with its own unique dimensions, fittings, and cooling requirements to an American airframe designed for a completely different power plant. It required sharing sensitive technology, rerouting production priorities, and convincing two massive military establishments to cooperate on a project that might not even work. It was a gamble of immense proportions, but the potential payoff was even greater. A fighter that combined the world's best airframe with the world's best high-altitude piston engine. The question was no longer what if, but how fast can we do it? The heart transplant that would create a legend was about to begin. While Rolls-Royce in Britain was stretched to its absolute limit, producing engines for the RAF, the solution was found across the Atlantic. The Packard Motor Car Company, a prestigious American luxury car manufacturer, had already been granted a license to build the Merlin engine in the United States. Their engineers, masters of precision manufacturing, had meticulously reverse-engineered the complex British engine and were producing a superb American version, designated the V1650. The key to this engine, the secret to its high-altitude prowess, was its magnificent two-stage, two-speed supercharger. Think of it as a transmission for air. At lower altitudes, the supercharger's impeller would spin at a lower speed, efficiently pumping air into the engine. But as the pilot climbed past 20,000 feet into the thin, oxygen-starved air, a clutch would automatically engage a second, higher gear. The impeller would spin dramatically faster, compressing the thin stratospheric air back to sea-level density before ramming it into the engine's cylinders. This device allowed the Packard Merlin to maintain its horsepower all the way up to 30,000 feet and beyond, an altitude where the old Allison engine was effectively useless. Engineers at North American Aviation were given 5 experimental P-51s and told to perform the surgery. They redesigned the engine mounts, reshaped the nose, and installed a new intercooler to handle the increased heat from the supercharger. The result was a new variant, designated the P-51B. When test pilot Bob Chilton took the first Merlin-powered Mustang into the air, on November 30, 1942, the transformation was nothing short of miraculous. The docile, low-altitude pony had become a fire-breathing, high-altitude dragon. The birth of the P-51B was not just an improvement, it was a revelation. The numbers that came back from the test flights were staggering, almost unbelievable. With the Allison engine, the Mustang struggled to reach 400 miles per hour above 20,000 feet. With the Packard Merlin V1650, the new P-51B screamed past 440 miles per hour at 30,000 feet. It had gained nearly 100 miles per hour in the exact altitude envelope where the air war was being decided. Its rate of climb was phenomenal, leaving its predecessor and most enemy aircraft far below. Suddenly, the United States Army Air Forces had a fighter that could not only match the best of the Luftwaffe, the latest models of the Messerschmitt Bf-109G and the Focke-Wulf FW-190A, but could outperform them in the high-altitude realm that the Germans had considered their private hunting ground. For the American generals planning the air war, men like Hap Arnold and Jimmy Doolittle, this was the breakthrough they had been desperately praying for. Here, finally, was the solution to the escort crisis. Here was a little friend, as the bomber crews would come to call them, that had the speed and the altitude performance to take on the German aces and win. The psychological impact on the command structure was immense. The despair of late 1943 began to recede, replaced by a surge of aggressive optimism. They now had the weapon. The question that immediately followed was a practical one. The P-51B could fly high and fast, but could it fly far? Could it go all the way to Berlin and back? Even with its revolutionary aerodynamics and the powerful new Merlin engine, the P-51 still faced the tyranny of distance. The ultimate goal was to provide a protective umbrella of fighters over the bombers all the way to the most distant targets in Germany, like Berlin or the aircraft factories in Poland, and all the way back home. A quick look at a map and a fuel consumption chart revealed a heartbreaking truth. Berlin was still too far. The P-51B carried a standard internal fuel load of 184 gallons. At cruising speed, this gave it a combat radius of around 500 miles. This was a significant improvement over the P-47 and P-38, but it wasn't enough. An animated map of a typical bomber mission tells the story vividly. The bombers would take off from England, form up, and head east. The Mustangs would join them over the North Sea. But somewhere over central Germany, hundreds of miles short of Berlin, the Mustang pilots would reach a critical point known as bingo fuel, the minimum amount needed to safely return to base. They would be forced to break off the escort, leaving the bombers exposed for the most dangerous part of their journey, the run to the target and the initial turn for home. For the Luftwaffe, this was a predictable pattern, one they had ruthlessly exploited. Their controllers would track the Allied formations, wait for the radio chatter confirming the escort was turning back, and then unleash their waves of fighters on the now defenseless fat cows. The perfect fighter had been created, but it was still chained to a leash that was just a little too short. The final piece of the puzzle was not about making the plane faster or a better dogfighter. It was about giving it the one thing it still lacked: endurance. How do you give a fighter with a small fuel tank the legs to cross a continent? The solution was an engineering trick as simple as it was brilliant. Give it more fuel to carry, but in a way that wouldn't compromise its performance in a fight. The answer was the droppable external fuel tank, or drop tank. Engineers designed streamlined aerodynamic tanks that could be attached to pylons under the wings, right next to the landing gear. These tanks would be filled with fuel, often carrying 75 or even 110 gallons apiece, effectively doubling the Mustang's total fuel supply. The pilot would take off with a full load, internal tanks and external tanks. The fuel system was cleverly designed to draw from the external tanks first. This meant that for the first few hours of the flight, the journey deep into Germany, the fighter was using up its disposable fuel. The precious internal fuel supply remained untouched. The moment the pilot spotted enemy fighters or was about to enter combat, he would simply hit a switch in the cockpit. An electrical impulse would release the shackles, and the empty or partially empty tanks would drop away from the wings, instantly shedding hundreds of pounds of weight and drag. The Mustang would be transformed in a split second from a long-range cruiser into a clean, light, and lethal dogfighter, ready for battle with its full internal fuel load intact. This simple but ingenious system effectively solved the problem of range. With drop tanks, the P-51's leash was cut. It could now reach any target the bombers could. In the brutal calculus of total war, every resource is precious, especially strategic materials like aluminum. Manufacturing tens of thousands of aluminum drop tanks, only for them to be used once and discarded over enemy territory, was a logistical nightmare and a massive waste of metal. The British, facing severe material shortages, had already pioneered a clever solution, and the Americans quickly adopted it. The breakthrough was a fuel tank made not of metal, but of paper. This wasn't ordinary paper, of course. It was craft paper, the same kind used for grocery bags, but impregnated with a waterproof plastic resin and laminated together under heat and pressure to form a stiff, durable shell. The tanks were constructed from these molded paper halves, fitted with basic pipes and a simple release mechanism, and then coated with a final layer of sealant. To the German intelligence officers who found the remains of these tanks scattered across the fields of Germany, they were a source of bewilderment. They looked crude, almost like a joke. They called them cardboard tanks. They couldn't believe that these cheap, disposable containers could reliably hold highly flammable aviation gasoline for hours on end. But they worked perfectly. A 75-gallon paper tank cost only a fraction of what an aluminum one did, weighed less, and freed up thousands of tons of critical aluminum for building the planes themselves. This seemingly mundane innovation was a stroke of strategic genius. It demonstrated the Allied advantage not just in high-tech engineering, but in a ruthless, pragmatic approach to mass production and logistics that the German war economy simply could not match. The road to Berlin would be paved with paper. Even with its new engine and long-range fuel tanks, the P-51B had one significant and potentially fatal flaw. A pilot's greatest asset in a dogfight is his vision, his ability to see the enemy before the enemy sees him. The cockpit canopy of the P-51B was a birdcage style, heavily framed, with a raised fuselage spine, or turtle deck, running behind it. This design created a massive blind spot directly to the rear. A German pilot could slide in behind a Mustang, unseen and unheard, and open fire before the American pilot knew what hit him. The solution came with the definitive version of the Mustang, the P-51D. Engineers took the bold step of cutting down the entire rear fuselage and replacing the old canopy with a single, seamless piece of blown plexiglass. It was called a bubble canopy, or teardrop canopy. This innovation, first developed by the British for their Typhoon and Tempest fighters, completely transformed the pilot's situational awareness. It gave him an uninterrupted 360-degree field of vision. He could check his 6, the vulnerable position directly behind him, with a simple turn of his head. There were no more blind spots. For the pilots of the Luftwaffe, this was a terrifying development. Their preferred tactic of surprise attacks from the rear was suddenly negated. A Mustang pilot could now see them coming from any angle, eliminating the element of surprise and turning a potential ambush into a head-on fight, a fight the Mustang was designed to win. Perfect aerodynamics and a powerful engine were now matched with perfect vision. The ultimate predator now had the eyes to match its claws. A fighter plane is ultimately a platform for its guns, and the P-51D was armed with one of the most effective weapon systems of the war. Instead of the cannons favored by the Germans and British, the Mustang was equipped with 6 Browning M2 machine guns, 3 in each wing. These were not rifle-caliber weapons. They were .50-caliber heavy machine guns, firing a massive slug of lead half an inch in diameter. Each gun could spit fire at a rate of over 800 rounds per minute, creating a combined storm of 80 rounds per second. The total ammunition load was 1,880 rounds, enough for about 30 seconds of continuous firing. While German fighters often carried powerful 20 mm or 30 mm cannons that could destroy a bomber with a single hit, these cannons had a low rate of fire and carried limited ammunition. The Mustang's 6 Medusas were a different kind of weapon. They were incredibly reliable, rarely jamming in the cold of high altitude, and their high velocity gave the bullets a flat, predictable trajectory, making aiming easier. A 2-second burst could pour nearly 160 .50-caliber rounds into an enemy aircraft. The effect was devastating. The heavy slugs could shred control surfaces, punch through engine blocks, detonate fuel tanks, and literally saw the wings off a Messerschmitt. Gun camera footage from the period is a testament to their destructive power, showing German fighters disintegrating under the concentrated fire. The P-51D didn't need one lucky cannon hit. It used a torrent of steel to guarantee destruction. December 1943. For the weary bomber crews of the 8th Air Force, it was a sight they thought they would never see. Flying deeper into Germany than ever before, long after the familiar shapes of the P-47 Thunderbolts had turned for home, a new silhouette appeared in the sky alongside them. They were lean, graceful, and fast. They were the first Merlin-powered P-51B Mustangs of the 354th Fighter Group, the Pioneer Mustang Group. The bomber crews, used to being abandoned to their fate, could scarcely believe their eyes. Over the radio, a B-17 pilot's voice crackled with a mix of shock and joy. "What are you? Who are you?" The calm reply came back. "We're the 354th Group, sir. We're your little friends." For the German fighter pilots of the Jagdverbände, it was an equally shocking but terrifying surprise. Their entire tactical doctrine was built around the predictable departure of the American escorts. They would assemble their formations, climbing to altitude, preparing to strike the vulnerable bombers, only to find themselves ambushed by these new, unknown American fighters. The reports that filtered back to Luftwaffe command were filled with confusion. German pilots described a fighter that looked something like a Bf-109, but had the performance of a high-altitude thoroughbred, a plane that could outclimb, outrun, and outturn them above 25,000 feet. The psychological tables had turned. For the Americans, hope was reborn in the frozen skies over the Reich. For the Germans, a shadow of doubt had begun to fall over their once uncontested aerial superiority. For months, the primary overriding mission of American fighters was defensive. Stick close to the bombers. Protect the big friends at all costs. This tactic, known as close escort, saved many bombers, but it was passive. It surrendered the initiative to the Luftwaffe, allowing them to dictate the time and place of engagement. Then, in January of 1944, a new commander took over the 8th Air Force. His name was General Jimmy Doolittle, the same man who had led the audacious raid on Tokyo in 1942. Doolittle was an aggressive, innovative airman, and he saw that the Mustang gave him an opportunity to change the entire nature of the air war. He issued a revolutionary and controversial order. He released the fighters from their defensive posture. His new directive was simple. Your first duty is to destroy German fighters. He authorized his Mustang groups to hunt. They were now free to roam far ahead of the bomber stream, to sweep entire sectors of the sky, to seek out and destroy the Luftwaffe wherever they could be found, in the air, on the ground, during takeoff and landing. The Mustang was no longer just a bodyguard, it was an assassin. This tactical shift from escort to fighter sweep was a declaration of total war against the Luftwaffe itself. Doolittle's strategy was brutal and direct. He was going to bleed the German fighter arm white. He aimed to achieve air supremacy not just by defending his bombers, but by systematically annihilating the enemy's ability to even get into the air. The effect of Doolittle's order on the German pilots was nothing short of psychological terror. Their world had been turned upside down. Before, combat was predictable. They knew where the American fighters would be and when they would leave. Now there were no safe havens. The Mustangs were everywhere. They would appear as tiny specks in the high stratosphere, diving out of the glare of the sun. They would be waiting for German fighters as they assembled to form up for an attack. Most terrifying of all, they began to follow the Germans home, strafing them as they tried to land, their landing gear down, low on fuel and ammunition. The airfields themselves were no longer sanctuaries, but death traps. General Adolf Galland, the charismatic leader of Germany's fighter force, later confessed the deep sense of dread this caused. "When I saw Mustangs over Berlin," he famously stated, "I knew the jig was up." The German aces, men who had tallied scores of over 100 victories, found themselves fighting for their lives against pilots with only a fraction of their experience, but who were flying a superior machine and, crucially, were backed by limitless numbers. The Luftwaffe was forced into a series of desperate tactical responses. They created heavily armed and armored Focke-Wulf 190s, the so-called Sturmgruppen, designed for single-pass attacks on bombers. But these heavy planes were slow and clumsy, easy prey for the prowling Mustangs. The attrition rate for German pilots, especially new ones, skyrocketed. For every experienced ace the Americans shot down, the Germans lost a leader and a teacher. For every Mustang lost, 10 more were waiting on the assembly lines to take its place. It was a war of annihilation, and the Luftwaffe was bleeding to death. When a P-51D Mustang met a Messerschmitt Bf-109G or a Focke-Wulf FW-190A in the skies over Europe, it was a clash of titans, a duel between the finest piston-engined fighters ever built. Each machine had its own strengths and weaknesses, and victory often went to the pilot who best understood them. The Messerschmitt Bf-109G was a superb climber and could turn tightly, especially at lower altitudes. But above 25,000 feet, the Mustang's two-stage supercharger gave it a clear advantage in speed and acceleration. An American pilot facing a 109 would try to keep the fight fast and vertical, using his superior energy retention to climb above his opponent and dive back down for the kill. The Focke-Wulf FW-190 was a different beast entirely. It was a brute of a machine, heavily armed, incredibly tough, and with a phenomenal roll rate. A FW-190 pilot caught in a dogfight could execute a snap roll and dive away faster than almost anything in the sky. However, the FW-190's performance suffered significantly at very high altitudes, and its turn radius was wider than the Mustang's. The Mustang pilot's tactic was to lure the FW-190 into a turning fight, where the P-51's superior aerodynamics and laminar-flow wings would allow it to get on the German's tail. Overall, the P-51D held the decisive edge. It was faster than both German fighters at the critical combat altitudes. It could outturn the FW-190 and outdive the Bf-109. Most importantly, its incredible range meant it could initiate these fights deep inside Germany, forcing the Luftwaffe to engage on American terms in a place and time of the Mustang's choosing. Was the Mustang truly invincible? Of course not. Every weapon has a vulnerability, and hundreds of skilled German pilots proved that the P-51 could be shot down. But when you look at the cold, hard statistics of the air war, a staggering picture of dominance emerges. In the European theater of operations, P-51 pilots were credited with destroying 4,950 enemy aircraft in the air, more than any other Allied fighter. For every single Mustang lost in combat to an enemy aircraft, they shot down, by some estimates, as many as 11 German planes. This kill-to-loss ratio was utterly phenomenal, far surpassing that of the P-47 or P-38 in the escort role. What accounted for this incredible success? It was the total package: speed, altitude, range, and the all-around vision from the bubble canopy. But it was also about numbers. By 1944, the skies were filled with Mustangs. A lone German pilot might successfully ambush one P-51, only to be immediately pounced upon by 3 others from the victim squadron. The majority of Mustang losses were not to the guns of Messerschmitts, but to the intense and accurate German anti-aircraft fire, known as flak, especially during low-level ground attack missions. Thousands more were lost in training accidents or due to mechanical failure. But in a pure air-to-air dogfight against the best the Luftwaffe could offer, the P-51 Mustang had proven itself to be the undisputed king of the sky. With the Luftwaffe largely driven from the high altitudes, the Mustang pilots took their war to the ground. Empowered by Doolittle's seek and destroy mandate, they began a systematic campaign to obliterate the German Air Force at its most vulnerable point, on its own airfields. After escorting the bombers to their target instead of heading straight home, fighter groups would descend to treetop level and scour the countryside for German air bases. The attacks were terrifyingly swift and brutal. A wave of Mustangs would sweep across an airfield at over 400 miles per hour, their 650 caliber machine guns ripping into the neatly parked aircraft. The effect of 48 machine guns firing simultaneously was catastrophic. fuel trucks would explode, ammunition dumps would cook off, and rows of parked Bf-109s and FW-190s would be torn to ribbons, erupting in flames before their pilots could even scramble for cover. This tactic, known as strafing, was incredibly dangerous. The pilots were flying directly into a hornet's nest of anti-aircraft guns, from heavy 80mm cannons to rapid-firing 20mm flak cannons hidden in woods and barns around the perimeter. Losses were often heavy, but the results were devastating for the Germans. They were losing more planes on the ground than they were in the air. For every plane destroyed on the ground, the Allies were also destroying a vital stockpile of fuel, ammunition, and spare parts. The Mustangs were not just shooting down the Luftwaffe's fighters, they were strangling the entire organization, destroying its infrastructure and its ability to ever recover. The last week of February 1944 marked the turning point of the entire strategic air war over Europe. The operation was codenamed Argument, but it would go down in history as Big Week. The objective was to deliver a knockout blow to the German aircraft industry by launching a series of massive, coordinated, round-the-clock bombing raids against fighter assembly plants deep inside Germany. For 6 consecutive days, over 1,000 heavy bombers, escorted by nearly 1,000 fighters, pounded targets in Leipzig, Brunswick, Gotha, and other manufacturing centers. This operation would have been suicidal just a few months earlier. But now the bombers had the P-51 Mustang. The Mustangs flew every single mission, providing a protective shield all the way to the targets and back. But they did more than protect. They hunted. The Luftwaffe had no choice but to rise and defend its factories, and they flew up into a perfectly laid trap. Swarms of P-51s met them, engaging them in huge, swirling dogfights that raged across hundreds of miles of sky. The results were a catastrophe for the Luftwaffe. During Big Week, the 8th Air Force lost around 200 bombers, a heavy but sustainable price. The Luftwaffe, however, lost over 600 fighters, and critically, 355 of its pilots were killed. These were experienced squadron leaders and flight instructors, men who could not be replaced. The German aircraft industry could replace the planes, but it could not replace the men. After Big Week, the Luftwaffe as an effective strategic fighting force was broken. It would continue to fight, but it would never again seriously challenge Allied air supremacy over the Reich. By June 6, 1944, the day of the D-Day landings in Normandy, the sky belonged to the Allies. As the largest amphibious invasion force in history crossed the English Channel, the soldiers looked up and saw a sky filled with friendly aircraft, fighters, bombers, transports, gliders, stretching from horizon to horizon. What they did not see was the Luftwaffe. The systematic destruction of the German fighter arm, a campaign spearheaded by the P-51 Mustang over the preceding 6 months, had paid its ultimate dividend. The German Air Force in Western Europe had been so thoroughly savaged that it was virtually powerless to intervene. On D-Day itself, the Luftwaffe managed to fly fewer than 200 sorties over the invasion beaches, a pathetic number against the more than 11,000 flown by the Allies. The Allied fighter bombers, with Mustangs flying top cover, roamed at will, attacking German troop columns, tanks, and supply lines, preventing reinforcements from ever reaching the front. General Dwight D. Eisenhower, the Supreme Allied Commander, knew that the success of the invasion depended on air supremacy. He later stated that effective, aggressive, and sustained air attack was a prerequisite for the success of Operation Overlord. That supremacy had been won in the brutal aerial battles fought by the Little Friends in the months leading up to the invasion. The P-51 had not just protected the bombers, it had cleared the skies for the liberation of Europe. One brilliant aircraft design can influence a battle, but only industrial might can win a war. The genius of the P-51 Mustang was not just in its design, but in the fact that it was designed for mass production. Edgar Schmuid had created a weapon that could be built quickly and efficiently by the thousands. The North American aviation plants in Inglewood, California, and Dallas, Texas, became monuments to American industrial power. The assembly lines ran 24 hours a day, 7 days a week. At the peak of production in 1944, the Inglewood factory alone was rolling a brand new P-51D Mustang off the line every 4 hours. Think about that. 6 complete, combat-ready fighters per day from just one facility. Overall, more than 15,000 Mustangs of all variants were built during the war. This torrent of production meant that losses could be replaced almost immediately. An entire squadron could be wiped out in a disastrous mission, and within a week it would be re-equipped with new aircraft and fresh pilots. The German war economy, strained to the breaking point, simply could not compete. For every fighter a German factory produced, American factories produced 5, 10, or even 20. The Luftwaffe was trapped in a war of attrition it was mathematically impossible to win. The P-51 Mustang wasn't just an airplane, it was the sharp point on an immense spear of industrial production that overwhelmed the Third Reich. With victory secured in Europe, the war's focus shifted to the vast expanses of the Pacific Ocean. Here, the strategic bombing campaign against the Japanese home islands presented a new and even greater challenge of distance. The new B-29 Superfortress bombers were tasked with flying very long-range, VLR missions from captured island bases in the Marianas, like Guam and Saipan, to targets in mainland Japan. But even these advanced bombers were vulnerable to Japanese fighters. The solution, once again, was the P-51 Mustang. From newly captured airfields on the tiny volcanic island of Iwo Jima, P-51Ds were tasked with escorting the B-29s on the final, most dangerous 700-mile leg of their journey to targets like Tokyo. These were some of the most demanding missions ever flown by piston-engined fighters, often lasting more than 7 hours, almost entirely over open water. The Pacific Mustang pilots faced a different kind of enemy. Japanese fighters like the Mitsubishi A6M0 were incredibly agile at lower altitudes, while planes like the Kawasaki Ki-61 Tony were formidable high-altitude interceptors. The American pilots adapted their tactics, using the Mustang's superior speed and diving ability to make high-speed slashing attacks, avoiding the turning dogfights that favored the Japanese. Just as they had done over Germany, the Mustangs on the Iwo Jima shuttle broke the back of Japanese air defenses, ensuring the B-29s could deliver their devastating payloads, ultimately hastening the end of the war in the Pacific. In the final desperate months of the war in Europe, a new and terrifying sound began to be heard in the skies over Germany: the ghostly whistle of the jet engine. The Messerschmitt Me 262, the world's first operational jet fighter, represented a quantum leap in aviation technology. With a top speed of over 550 miles per hour, it was more than 100 miles per hour faster than the P-51 Mustang. In a straight and level race, the Mustang stood no chance. When Me-262s attacked the bomber formations, they would slash through at speeds that made them almost impossible to track and hit. For the Mustang pilots, it was a shocking and humbling experience. Their king-of-the-sky fighter was suddenly obsolete. However, the jet had critical weaknesses, and the American pilots, demonstrating incredible courage and tactical ingenuity, quickly learned to exploit them. The Me-262 was vulnerable during its long takeoff run, and especially on its final approach to landing, when it was slow and unmaneuverable. Mustang pilots began to orbit German jet bases, waiting to pounce on the Tu-162s at their most helpless moments. They also used their vast numerical superiority. A single Me-262 might be attacked by an entire squadron of Mustangs, diving from above to build up speed, forcing the German pilot to maneuver and bleed off his energy advantage. While the Me-262 was a glimpse into the future of air combat, it arrived too late and in too few numbers to change the outcome of the war. The piston-engined P-51 Mustang, the master of the skies, held its own until the very end of the propeller era it had so completely dominated. How did one airplane change the world? The story of the P-51 Mustang is the story of a perfect convergence of brilliant ideas. It began with Edgar Schmude, a German immigrant who gifted America a near-perfect aerodynamic body, complete with the revolutionary laminar-flow wing. This created a platform of unparalleled efficiency. But this brilliant body was shackled to an earthbound soul, the Allison engine. The second genius was the suggestion by a British test pilot to perform a heart transplant, to give this American airframe the high-altitude power of the British Rolls-Royce Merlin engine, perfected for production by the American Packard Motor Company. This combination created the ultimate high-altitude thoroughbred. But even this champion couldn't win the race without endurance. The third stroke of genius was the simple, pragmatic application of droppable fuel tanks, first made of precious aluminum, then of throwaway paper, which gave the Mustang the incredible range it needed. Finally, the bubble canopy provided the perfect vision required for a Predator. Any one of these innovations alone would have made a good fighter. The combination of all of them, aeronautics, engine, range, vision, and the lethal punch of 650 caliber machine guns, created something close to perfection. It was the right machine, at the right place, at the exact right time. Edgar Schmude and his team at North American Aviation didn't just build an airplane. They built the key that unlocked the skies over Europe and enabled the victory of the Allied cause. In the grand tapestry of the Second World War, the P-51 Mustang is more than just a piece of machinery. It stands as a symbol. It is a symbol of engineering genius, the fusion of American and British innovation that created a weapon greater than the sum of its parts. It is a symbol of industrial power, a testament to a nation's ability to turn its factories into an unstoppable arsenal of democracy, producing weapons on a scale the world had never seen. But most of all, it is a symbol of a strategic promise fulfilled. It was the little friend that promised the beleaguered bomber crews they would no longer have to face the horrors over Germany alone. The Mustang was the instrument that shattered the Luftwaffe, cleared the way for D-Day, and ultimately brought the air war to the enemy's doorstep. From a rejected design with the wrong engine to the undisputed master of the sky, the P-51's journey mirrors the story of the Allied air campaign itself, a story of early failures, painful lessons, brilliant innovation, and eventual, total, and uncompromising victory. It proved once and for all that a single, perfectly executed technological idea, when wielded with courage and built in overwhelming numbers, has the power to change the course of history.